Can you hear me?
Hello, hello.
Hello,
I
can you hear
can
me?
hear you now.
Okay,
Mm,
all right. Lisha, I'll get to your question later. Okay, so let's talk about this slide that we're looking at. Let me share my screen again. Okay, all right. So here we're talking about this particular set of ovals, right? When we're talking about J train, it means that it is in perpendicular a gradient, right? So if we are talking about the gradient, which way does it point? Okay, it's going to point in this direction, right?
but why is that so? Sorry. I think this might be a math question, but why is it pointed in that direction?
Because when we look at the manifold, okay, basically the heat map of which way the regularization solution is getting better, right? We find that the best solution is going to be here, right?
Okay.
Okay, as we saw on the
I
heat
see.
maps um, from the previous slide. Okay, so
I see.
let's pretend that uh, the best solution is at W at theta lin, right? This position.
Ah.
Okay,
Mm.
so when we draw these contours, these ovals around this means that the loss function is constant.
Okay.
So
Mm,
then what's going on is that when we look at any of the positions on this oval, the gradient is either has to be facing a perpendicular to this line, right?
mm, mm,
Okay. So it's going to be pointing in the direction where the gradient, the loss function is increasing, right? That's what the gradient is.
okay.
So we want it to point, the right one that we want to optimize should be pointing inwards, right? So it should be the
I
negative of
see.
the gradient. Does that make sense?
Okay. Yes, I understand now.
Okay, great.
Then a related question, if I may.
Okay,
I think it's in the next slide.
okay,
It's in the next slide about the. Yes. Could you explain the direct proportion here again? The
okay, on the bottom, right?
yes, that's right.
Okay, so what we're trying to say here is that the budget, okay, that you have, okay, is basically dictating the size of this circle, right?
Mm,
So if you have a bigger budget, this circle can be larger. If you have a smaller budget, it would be smaller, right? So if I have a smaller budget, maybe it'll look a little bit like this, okay? And if I have a larger
mm,
budget, maybe it'll look a little bit like this one, okay? So there's a correspondence between our budget and the amount of regularization that we're going to use when we think about it in terms of a tuning parameter, right? So this tuning parameter here.
mm-hmm.
Okay, so that's why we say there's a proportionality between the regularization and the lambda. Okay, so the lambda is going to go down depending on the amount of budget you assign. Okay, so the more the budget you assign, the more lax the regularization is, right? Because if you have a lot of budget, you can afford a very wide solution, maybe something like this. And in this case, right, theta lin is already inside the solution set, so you don't need to regularize at all. Does that make sense? Your budget is
Mm,
so big that it encompasses the ideal solution, so no regularization will be used. Okay. On the other hand, if you have
okay.
a smaller budget, like the one that we show, okay, like this one here,
Mm-hmm,
all right, then our budget is not enough to afford the optimal, right? The optimal is the one that's pointed out here, right?
mm,
Okay, the one over here. Okay, but we can't get to that with the solution, so we can only afford to get the point that's over here. Okay, and
mm,
we're basically saying that to find this point, we just need to make sure we understand that the gradient of the loss function and vector, the normal to the circle, right? The L2 regularization would be opposite each other. Okay,
mm.
does that make sense? So because we have
Sorry,
this normal coming from the circle, okay, and this loss functions, J train pointing in the opposite direction, when these two are exactly pointing in the opposite directions to each other, that is the correct spot for us to choose the best solution, to this problem. Okay, so we have to choose here. We could have chosen any spot on this budget. We could have even chosen something inside, okay? But the place where it minimizes the loss function would be at the tangent, right? When the circle meets the ellipse. So we would have to choose this green spot.
Okay. I
Okay.
think I understand the pictorial, like the representation of it, but I think I'm kind of confused. Like, what are these terms here? The delta of J train of theta regularization is proportional to the negative of theta regularization.
Okay. I think this is just notation that you want to understand for, how much regularization you want to put in. Okay, so it's relating to the size of the circle.
Size of the circle. So theta regularization denotes the size of the circle?
It's proportional to, yeah.
Proportional. It's proportional to, okay.
Okay,
So
it doesn't matter exactly whether it equals or not, right? We're just basically
okay.
saying that when we have a larger C, our circle expands, right? As we have written over here, okay?
Yep,
All
okay.
right, and then when we have a larger C, then the amount of regularization that we're getting, our bang for the buck, is getting smaller, right? So we can encompass a larger set of solutions. The larger set of solutions usually means we can encompass better solutions that are going to minimize our J train more, right? Because we're
So
getting
if we have
closer and closer to our
okay,
solution of theta lin.
that is if we have a larger C, right? Like a bigger,
Yes.
larger budget.
Yeah.
So
So you can think
therefore,
of it as expanding the circle, right?
okay, and the gradient, I see, and the gradient will become the gradient of J train. If we have a larger C, then that means this term is going to be tending to zero. Is that right? Because lambda decreases.
Well, the gradient is going to be larger the farther away we are from W lin, right?
Okay, okay.
Okay, so the smaller we make the circle, the larger
Ah,
the
the
gradient is
gradient will
going to
be.
be.
I see. Okay, okay. I understand now.
Okay.
And the two is just chosen out of convenience, right? I
Yeah,
think.
that's because of the square, right? So when we differentiate, usually the 2 comes down, right? So we're just choosing it for convenience, so the math will work out. But
Okay.
here we're not emphasizing the math for this particular lecture.
Okay. No problem. Okay.
Okay, it's
Thank
just
you.
there to be accurate.
Yep. Okay. Yep. I'll give my chance to others to ask questions then.
Okay, thank you. So Charlie or Lishuo, did you have questions that you wanted to cover? Otherwise, what I'll do is go through the ethics pre-lecture part, but I'm happy to take your questions instead. Yeah, I may have missed something on chat, so I'm just going to double check whether we have anything on chat. Okay, and there was a ask me anything part, but I don't think there's anyone who's asked anything there. Oops. Okay, so let's go ahead and go through a little bit of the lecture. Is that all right with everyone?
Okay.
Okay. So I'm going to do that, and then it won't take so long. So I think what we'll do is we'll still have some time to cover what your questions are later. Especially, I know there are lots on the forum, so I'm trying to get to those. We have a number of other things that we need to do for the course to make sure your grades are intact for the tests and to make sure that the proctoring is going to get set up properly. But again, in case you didn't receive the emails, there will be extra help sessions today, one from 3 to 4, and another one from 11 o'clock at night to 1 o'clock in the morning. how much math will be tested in the final? So the amount of math is going to be very similar to what is in exam one. So we're not going to ask you a tiny bit of, we're not going to ask you a lot of the math in uh, in detail, right? Because a lot of the math you can pick up on your own if you actually need to carry it out in work, okay, or in a project. The important part is to understand the concepts that are at play, and then to be able to use it in the appropriate setting. So for example, in week 11, if you're not quite sure of the math, we can definitely go over it a little bit more. I think we went over it a bit during the help session on Monday, and I think Lee Shore, you were there. But if you're not clear, then please fire away, and I'll try my best to give you a better understanding. Again, the story that we want you to understand from week 11 is that there are lots of cases in which we can either use, something like what was it? Um, Expectation maximization, right? This idea that we can alternate between two different components, right? Or even more than that. Okay, the basic idea is you hold one set of things constant and assume that the other ones, sorry, you hold one set of things that you want to investigate while holding the rest constant, right? It's easy to do when there's only two things, right? So all of the cases of EM that we talked about are only of two items, right? Either the model that you hold constant and re-estimate the latent variable to which cluster things belong to, and then flipping it the other way, whereas you have um, sorry, the the memberships stable, okay, you're holding those as constant, and then you're using that membership to re-estimate the model parameters, okay? So I can go over that, no problem. I don't think you have to worry too much about the math, but if you're worried about it, yeah, I totally understand there's a lot of technical content, but again, we are not really pushing you on that, okay? It's just the framework for EM that you need to understand. Okay. So yeah, ask away. I think those are important that you have a good understanding of what we're looking for and the ideas that we want you to get. Okay. So let me go open this week's lecture.